Hello, welcome to my channel. In this tutorial, we want to treat division of polynomial as the continuation of our topic, polynomial function. If you are new, consider to subscribe to the channel for more of my videos. From the beginning of our series, we define a polynomial to be any function of this form whereby the powers of x, that is the variable, keep on decreasing from the right to the left, where the a subscript n minus 1, 1 and 0 are all constant, or in this case these are coefficient of the variable x, where the last one is the constant of this polynomial. So any function that is of this form, where the a subscript n is not 0, we call this a polynomial function. So we are saying that if a polynomial function f of x in this form can be divided by another polynomial function g of x, then it means that the degree of the function f of x should be greater or equals to that of what? G of x. Simply put, if we send our mind back into rational function, we can explain this concept here, mean that we can only divide polynomials that are improper fraction, as in x exponent 4 minus 1 over x exponent 3 plus 2. This is improper fraction, whereby the power or the degree of the numerator is bigger than the degree of what? The denominator. That is what this explains. Or we can have 3x squared plus 1 over x squared minus 3. This can also be divided, since this is a polynomial of degree 2. They have equal degrees. So this is what we can divide. If it becomes proper fraction, as in exponent of 2 over exponent of 3, and this cannot be divided, then we move away from polynomial into a rational function. Now, this division is also possible, as we are seeing f of x divided by g of x. This division is possible if this is a factor of what? F of x. If the g of x is a factor of f of x, then we can easily divide this fraction. So as we can see in let's say 8 divided by 4, we know that 4 is a factor of 8. Therefore this division will give us 2 with no stress or remainder or any other additional number. Now, it is not always that our g of x will be a factor of f of x, as in the case 9 over 4. We can see in this case that 4 is not a factor of 9, but still we can perform this division regardless. So this will give us 2 plus 1 over 4. We know it's going to be 2 whole number 1 over 4. The 1 is not up to 4 to be divided. So we can do same. So similarly, if you have a polynomial whereby the g of x is not a factor of, it means we can still have f of x, g of x equals to our quotient polynomial or quotient function, then plus our remainder, which is going to be also a function of this, divided by our g of x. So if you are dividing any polynomial whereby the denominator is not a factor of the numerator, your answer is going to be presented in this form. Meaning after you get your quotient plus the remainder over your divisor. In this case, if I want to maintain the f of x, I can multiply through by g of x. Meaning if I multiply, I get f of x equals to quotient times the divisor plus what? The remainder. Don't forget, if you multiply here by g of x, it cancels. As we can get here. As in the case of this, multiplying through by 4 will be 9 equals to 2 times 4 plus what? 1. 2, 4, 8 plus 1 is 9. So we can only do this in two forms. We have denominator being a factor of the numerator, meaning you get one single answer. But there are cases whereby your denominator is not a factor of the numerator. Bear in mind that you'll be getting a remainder function. Alright, now to divide polynomial, we have two methods of division. That is the long division method and the synthetic division method. Now, the long division method is widely used because it has no restriction. But the synthetic division is not widely used because it has a limitation. Meaning, our divisor, denominator, can always be x minus a. Meaning, it can always be a linear function. Whether x minus c, x minus 5, in that order. The moment the power changes to 2, we cannot use synthetic. So in this episode, we will be treating the long division method or approach, which we know that we are going to use a bar where our dividend will be in the vertical sign, where we have our divisor in front. Whatever calculation we have, give us an answer called what? Quotient. So the quotient will be there. Meaning, how we can represent this is on this function equals to what? Quotient. Meaning, whatever is here is our answer. The numerator as we have here is our what? Dividend. Then the divisor is our what? Denominator. In case I want to divide this particular polynomial by x plus 3. So in this case, we know the question is going to be divide this by this, or find out whether this particular function is a factor of this. Now, in the division by long division, we are going to employ the principles of indices. So where we know that if I have x to the power 4 divided by x to the power 2 in division, we subtract the powers. As in x to the power 4 minus 2, the powers will be subtracted. So you are going to employ the same principles in this calculation. So anytime I said x to the power 3 divided by x, in my mind, I am only going to subtract the exponent. So 3 minus 1 will give me 2. Imagine there is a coefficient here. That coefficient will perform its division, normal division. But I'm referring to the variable, which will be used as indices. Alright, that is 1. 2. Our division is always by the first term of the divisor and the first term of the dividend. All this will not be touched, but they will be used in the calculation. But it is always the first and first throughout. Then your quotient will multiply whatever is here to generate your sequence that you are looking for. So let's go. When x divides this, you know the power of 1 will subtract from this to give us power of 2, meaning 6x squared. So we're going to have 6x squared as our quotient. That quotient will in turn multiply every term here, starting from the first one. When we use the multiplication law of indices, when you multiply base of the same power, of the same variable, you add the exponent, meaning 1 plus 2 will give us 6 exponent 3 back. Then 3 will in turn multiply the whole of this, then that will be 18x squared. So we are done. We perform our subtraction. 6 minus 6 obviously will be 0. Then 17, don't forget the powers are the same, so only take care of the coefficient. 17 minus 18. 17 being smaller than 18 give me minus 1 times x squared minus x squared. So now we are done with the subtraction, but there are excess terms. So we indicate the minus 5x minus 6. So this becomes another dividend to be divided by the same divisor. So x will go here again. Don't forget, this is just a coefficient, so minus 1 is there. You keep it. X dividing x squared, meaning x squared minus 1 become what? Only x to the power 1. So minus x. Now the answer comes back and multiply to give me minus x squared minus x times 3 minus 3x. Then our division again. This is going to be minus 1 minus negative 1, which we know become minus 1 plus 1. And this will give us 0, meaning the front is going to be 0. Then here become minus 5 minus negative 3, which become plus. So since their signs are different, we subtract and keep the sign of the bigger one. So minus 2. So here become minus 2x. Then we bring down our minus 6. So another dividend is arrived. So what do we do? This as x dividing itself. So x divided by x. We know power of 1. Power of 1. So x power of 1 minus 1 become what? 0. That is 1. 1 times minus 2. Still minus 2. Minus 2 times x. Minus 2x. Minus 2 times 3. Minus 6. Let's perform subtraction. This will be 2 plus minus 2 plus 2, 0. Minus 6 plus 6, 0. So bear in mind that our division continues. You continue dividing until you either get 0 or you get a variable whose degree is smaller than the degree of the numerator. Meaning if this were to be exponent 3 plus 3 and I end up getting x squared. So since this is smaller than this, I may not be able to divide because we said polynomial has exponent of positive values. Don't forget, if you subtract this, it will be x squared over x to the power 3. Meaning x squared minus 3. X is going to be minus what? Negative 1, which defeats the polynomial rule. The exponent must always be positive, not negative nor fraction. So the moment you see a degree in your dividend being smaller than this, meaning you are having a proper fraction, so you stop at that point and that becomes your remainder. You will treat a remainder theorem in the next episode, but in this division, meaning if I'm to divide this 6x to the power 3, 17x squared minus 5x minus 16 equals to our divisor, which is x plus 3 multiplying 6x squared minus what? X minus 2. Don't forget we said the function equals to the quotient, which is this, times the divisor, which is the same thing, commutative multiplication. So this equals this by factorization or by division. But we can see this is also a quadratic that can easily be factorized. So we do that easily to have our this. Since the coefficient of x squared is not 1, we use that to multiply this. So give us x squared minus x minus what? 12. Then your x plus 3. We know the answer is going to be in 2 brackets, while the first will be x in each bracket. So now we are looking for factors of negative 12. When you add, you get negative 1. And those could be negative 4 and what? 3. So putting in there, negative 4 plus what? 3. But don't forget, we have altered the question by using 6 to multiply this. So now we reverse it by dividing these answers by that 6. So from that, if I do that, it's going to be x minus 4 over 6, x plus 3 over what? 6. Per division, this will become x minus 2 over what? 3. X plus 1 over what? 2. Since we can't have a fraction here, we multiply through by 2, meaning these 2 will shift to the coefficient, these 3 will shift, meaning 3x minus 2, 2x plus 1. So our answer is going to be first 3x minus 2, second 2x plus what? 1. So this is our actual answer if we are to divide this function by this, meaning x plus 3 is a factor. X plus 3 is a factor of 6x cubed plus 17x squared minus 5x minus 6, meaning there is no remainder. Alright, so these are all under division by long division. So we will do more examples in the subsequent episodes so that you understand the whole concept clearly. Thank you for watching. If you do like this video, don't forget to share with your learning mates. Subscribe to the channel if you are new and leave a comment. Bye bye.